Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about 3 practical use cases of Optane persistent memory with MemVerge. Today's show, we have the CEO of MemVerge, Charles Fan, a friend of mine. We've talked to him on the show before. We've worked before. It's great to have you on the show, Charles.
Hey, Darren, thanks for having me. Great to be back.
So we talked to you guys almost a year ago when MemVerge first launched its first product. I'm sitting on Intel's persistent memory, Optane persistent memory. It's been almost a year. How are things going, man?
Things are going great. So we shipped the first version of our software in September last year. And despite the pandemic, which certainly slowed down, the education of brand new technology to the customers, that we do have a number of customers using our technology with Optane persistent memory. And we are seeing a good pattern emerging in terms of what type of use cases they are using it for. So we are pretty excited about that.
It's amazing because you guys actually took a technology that Intel created and created a whole new way of doing compute with it that is really fundamentally changing not just one industry, across several different industries, which we're going to talk about just 3 today that are profoundly shifted because of your guys' software.
That's right. But our software wouldn't be able to do this without the underlying hardware innovation. I think persistent memory, in particular, Optane persistent memory, is a breakthrough technology that blurs the line between memory and storage. And that opened up many possibilities. And our software is trying to explore some of these possibilities and to be able to deliver something that was not before possible. So it's really an example of hardware innovation and software innovation working hand in hand.
Yeah, and I love how you said that, because I see it as a fundamental change in the traditional compute architecture that we've been doing for the last 50 years.
That's right. I think in your traditional von Neumann model, you have the computing unit, you have memory, you have the I/O device, storage.
Yeah.
And whenever you're moving from one block to another block, that's where the bottleneck is. There's a CPU memory block, the von Neumann block. Then there is a memory storage bottleneck, and that's the storage I/O bottleneck. And what we are doing together with Intel is really to remove this bottleneck between memory and storage by combining them into a single pool of resources.
Boy, what are all those computer science college textbooks going to do? They're going to have to be rewritten, I hope, right?
Yeah, more business for the publishers.
That's right. See, you're creating a whole new industry on the side.
But that's not one of the 3 we're talking about.
No, that's not
today.
one of the 3. Let's talk about these use cases, because these were really interesting when your team talked to me about them. Because I remember when this first came out, I was like, oh, I know where I want to use it. And I was going off in one direction. You guys are going off in another direction. And holy cow, you guys found some really cool use cases for this. Let's talk about those.
Sounds good. So maybe let me tell you what are the top 3 that we have identified, and then we can go one by one, kind of go into more details of each of them. So the 3 use cases we have found. Number 1, we have been working with a number of cloud service providers. As we know, the world is going to cloud, and the key metric for a cloud service operator is how many VMs can they deliver to their customers and at what cost. So this per VM cost is a key metric to measure the efficiency of a cloud service provider. And often the size of memory on the servers become the bottleneck of how many VMs you can allocate per server. Therefore, that limits how low your price per VM can go to. Now we bring in Optane persistent memory and MemVerge software. We can deliver larger amount of memory per server therefore allocate more number of VMs, therefore the per VM cost become lower. That increase the competitiveness and increase the margin for the cloud service providers. So this is the first use case.
Yeah, so this is an interesting use case because in some cases you're talking 2 to 3x cheaper per VM.
Right.
Especially with MemVerge, because MemVerge uses all the memory, not just the persistent memory with the DRAM cache.
Right.
You use all the memory for all those VMs.
That's exactly right. So just to give you an example, a typical server before Optane, could have 512 gig, 768 gig. That's a very big system with a good amount of memory. And let's say if you need 32 gig per VM, you can have 20 VMs or 200 VMs or so on. Yeah, so if you need 32 gig per VM, it's about 20 some VMs you can have on that server, and that's guarded by the amount of memory you have. And now if we bring Optane into the server, you could have 3 terabytes of Optane in addition to that 512 or 768 gigabytes of DRAM. And with MemVerge software, we can deliver the combination of that capacity, 3 terabytes plus 768. So you get 3.7 terabytes of memory now available on your server. So if memory is your bottleneck, instead of 20 some VMs of 32 gig VMs, you could have over 100 VMs. So therefore the per VM cost go down really, 3 times. The server will be a little bit more expensive, but you get 5 times more VMs. So the per VM cost could be 3 times cheaper, and that really increases the competitiveness of the cloud service provider.
All right, so that could also be used in my own data center as well. If I want to do this on-prem, I could do the same thing, right? I want to compact more VMs. And we also, I know we ran some tests with your team around over provisioning memory. Yeah. And we found that we can do that really easily because most of those VMs are sitting idle. So even over provisioning them, I'm not going to take a hit in performance. And I can even squeeze out probably another 20 to 30%, which is quite incredible when you think about it.
That's right. Public cloud is where we're starting with. This certainly is applicable to private cloud and your own data center. But with public cloud, this is their bottom line.
They squeeze every penny out of every instance.
So this become a very strong use case for us and for Intel and for them.
Great. Okay, what about the next one? What about the next use case?
Now the second one. We have been working with financial customers, actually since the beginning. Probably the last time we talked about some of these financial customers, stock exchanges, banks, the mutual funds, hedge funds, and etc. And they use a lot of in-memory databases and in-memory applications. Some of them homegrown, some of them third-party. And there's a problem with these in-memory applications. Number one, memory is not big enough. We already know we do big memory solutions, so there must be a fit. We can make the memory bigger so they can have more instances, bigger instances per server. But also, these in-memory databases sometimes have availability challenges. That's because their data are not being persisted to the storage all the time. The data during the trading day are usually just in memory. Now, if, God forbid, you have a crash, then you lose all your data. All the intraday data in memory will be lost. And it is catastrophic. You either lose those data, or even if you have logged all your transactions, you will need to replay the log to recover the database. That often takes many minutes or even hours to recover a database from a crash. And so what we offer, in addition to offering bigger memory size, is we offering a new data service that's called in-memory snapshot, that we can persist the database state onto Optane persistent memory. It's much faster than persisting it onto storage. And therefore, if you crash, you still have the data, the last snapshot captured on persistent memory, and you can recover from that, and that become a much faster, much less RTO
So
than
how
the
much
previous case.
faster are we talking? Let's say my machine reboots, okay,
Yeah,
and I come back up. How much faster? Because before you were talking hours to
right.
replay the journaling logs.
So now the reboot plus recovery will be like a minute or two. So you can basically
Whoa.
reducing from an hour or two to a minute or two, during these reboot.
So we're talking 60 to 100x
Right,
performance improvement.
exactly. Almost 2 orders of magnitude improvement in terms of
All right.
work.
So you've hit two major things that most CIOs worry about: cost
Right,
and reliability.
that's
Right.
right.
Because that keeps my systems up for even if I do have a crash, it comes up faster. Right.
That's
So
right. That's right.
that's big. All right. So
And
that's huge.
that's a good segue
Yeah.
into the third use case, because that's going to give you performance and productivity. And I think, as a CIO, you care about cost, you care about reliability, availability, and you care about ultimately the productivity of your team, how fast. The whole purpose of IT is to increase productivity of the workforce. And how can you build a foundation, build a tool set, allow your employees, the creative minds, to work on things faster. And that's a good segue into the third use case, that we have actually found a number of users in the genomics, bioinformatics area are using the combination of Intel Optane memory and MemVerge software to underlie their multi-stage data analytics workflow. And with that, number one, again, we deliver bigger memory so that you can have more parallelism of your pipelining and processing. So the whole thing can be faster. But also our snapshot becomes handy here as well. The reason is, with these type of jobs, let's say they are doing a cancer research or they are doing some COVID research, and they need to do all these analytics on these many DNA, RNA sequences, and they need to go through like 11 or 20 or 50 stages of processing. And each stage will take from minutes to hours. And after each stage, they need to take a checkpoint of the state of that intermediate computation results for a couple of reasons. One is sometimes you need to roll back and rerun it to just verify you can reproduce the results. Secondly, sometimes they want to modify some data and then do some they call what if analysis to compare how they will differ if you make change of some parameter or some sequences, and to see how the results will differ. And how they do it today is they would take these checkpoints and save that state onto storage. And this takes anywhere between 5 minutes to like 30 minutes for them to do these after each stage, to do these IOs. And these IOs turns out in many cases to be more time consuming than the compute itself.
Oh,
It is a
wow.
compute intensive. So if they use like 24 hours to do the job, they could use 8 hours on compute, 16 hours just doing these IO jobs to saving those intermediate state. And so you can probably guess how we can serve them is that instead of doing IO, what we do is we use snapshot. So after each stage, they just take the snapshot and capture that on the Optane persistent memory, and they keep running. So instead of 16 hours of IO, now these snapshots take, total like a single minute. So essentially you almost completely eliminate what they call the IO wait.
You know what? This is opening up a whole bunch of workloads that I used to run a lot of workloads in HPC clusters.
Right.
Right. Even I'm thinking testing software, testing hardware. I mean, the list goes on and on that I don't have to store this out to a drive. I just take a snapshot of the memory and move it to the next phase.
Right. It's like the new way of doing IO. You don't need to do the serialization, deserialization, open the file, read and write, and doing all that, block access. All you have to do is just take a snapshot. and that just
Man,
completely rewrite the rules of
this one's probably the one that's leaning more towards the new way of computing more than anything.
That's right.
Right. Because before, why do we have hard drives? Because I want to save something so I can look at it later or use it later. You're now using the persistent memory to just snapshot it, and it's there.
That's right. That's
now,
right.
Isn't this going to take a ton of memory? I mean, come on, Charles.
Yeah.
I only have let's say I load a machine all the way up, our brand new Ice Lake machine with your stuff, 2 sockets. I'm getting probably 7 or 8 terabytes.
Yeah.
Right in that range, 7 or 8 terabytes fully loaded.
Yeah.
If I'm running these stages through, I'm generating data as I go through. I'm taking snapshots. I'm gonna exhaust all that persistent memory. Right.
So you are right, and there are 3 answers to your question, and this is a important question. Number 1, for sure the memory is bigger than before. So just the combination of Optane and DRAM offers a bigger memory pool. And so that's good. And that's going to keep increasing as Intel continues to innovate, increase the density of
and we will. We'll make exactly.
more. So, but that certainly does not fully answer your question. So we are looking at how we can optimize this from software perspective. And we included 2 features. The first feature is really the key IP that we have. The reason we call this snapshot rather than checkpointing is that we can do this periodically, repeatedly, without creating full copies of the memory state. So what we do is we do a natural dedupe between the subsequent snapshots where only capture the changed pages so that the extra usage of memory can be minimized. So if you take 10 snapshots, you do not use 10x the memory. In fact, if you do not change your memory, you just use 1x of memory. You have no extra use of memory. We only capture the changed pages.
Okay, that's good. So that's good. That's going to help me out quite a bit.
Right. So that's really the key thing, how we can make the memory usage capacity-wise to be efficient. And then we add another capability, is that if you do these subsequent snapshots, we can keep up to 256 layers of snapshots in memory. But at the same time, we allow you to, we call export or move those snapshots off memory to some storage service or storage systems that you have. So I
could do that out of band of my.
You can do that out of band in the background without impacting your, without interrupting or impacting your running application.
So that's super cool, because I can totally see me putting a workload together that says, run this workload in step 1, start offloading at the same time, move to step 2. And even though the offloading is happening in parallel, it's not interrupting the CPU, CPU states.
Exactly. Yeah.
That's slick. That is super slick.
Right. So I think our customers are really enjoying this. And essentially we are creating I call it a memory DVR. So, before your application can only run forward.
That's right. Now I can run forward and backward.
Right. Now you can roll back. You can do all that almost instantly. So this gonna give you a new experience.
I think my crazy brain is thinking of a new programming paradigm.
That's right.
I just have one big state machine that just cycles through. I mean, I can move back and forth in memory. That's so cool.
Right. So the genomics is just the first example of this. There are probably other workloads that can benefit from this, but we are a startup, so we are starting narrow. So we are focusing on these 3 areas: cloud service provider, financial, in-memory applications, and genomics and related data science kind of pipeline jobs, and to just prove out the power of the combination between Optane persistent memory and MemVerge software.
Great story. I think you guys are right at the tip of the spear of this whole digital transformation. I can't wait. My brain's going crazy on the things I can now do or possibly do. We'll have to talk offline. Maybe we'll have to come up with You'll say, Darren, yeah, that'd be great. I'm a startup. I don't have 1,000 people to throw at problems. So
yeah, we are learning every day as well, working with customers. I hope I'll be able to come back, in a few months and maybe tell you more customer stories how our
absolutely
technology is being used.
Hey, thanks for coming on the show today, Charles, and good luck with your endeavor with MemVerge.
Oh, my pleasure, and thank you for having me.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.